In this session, we'll be mainly focusing on spatial filters. Now let's have a look at what exactly spatial filtering is. Now, use of different spatial masks for image processing is done by using spatial filters. Now, there are basically linear as well as non-linear filters, where low-pass filters eliminate or attenuate high-frequency components in the frequency domain, sharp image details, and result in image blurring. Now, this is basically a representation of a general spatial filter mask. We have represented it by using 3x3 matrix. Now what we have done is, there are two 3x3 smoothing filter masks. The constant multiplier in front of each of the masks is equal to the sum of the values of its coefficient as is required to compute an average. This is the reason why we have multiplied the first matrix by the multiplier 1/9 and the second matrix by the multiplier 1/16. Now, what exactly smoothing is? We mainly have median filtering under it, which is also known as non-linear filtering. Now, median filtering is primarily used for noise reduction. Noise reduction is basically reducing all the unwanted signals present in your original data. So it basically eliminates all the different isolated spikes. The gray level of each pixel is replaced by the median of the gray levels in the neighborhood of that particular pixel. So basically what happens is, for each and every pixel, we take into consideration the pixel which is in the immediate neighborhood of that particular pixel, instead of by the average as before. As you can see, in the previous case we were considering the average. Now we are replacing it by the gray level of its neighborhood. Now this is a proper example of averaging and using a median filter. You can see the first image is the original image. The second one is the one added with noise. As you can see, the moment noise is added to the original data, the image quality goes down and the image turns out to be blurred. The third image, as you can see here, is an average image. Average image also provides you a good quality image, but less as compared to the median filter. Whereas if you take into consideration median filter, it provides the best quality, and this is why median filtering is used for the purpose of smoothing. Now what exactly smoothing is? Low pass filtering, also known as smoothing, is employed to remove the high spatial frequency noise from a digital image. So main work of low pass filtering is to remove the high frequency noise. These low pass filters usually employ moving window operator, which affects one pixel of the image at a time, changing its value by some function of a local region or the window of pixels. The operator basically moves over the image to affect all the pixels in the image. We have learned what exactly smoothing filters are. Now let's see what sharpening filters are. It can be said that the main aim of an image sharpening is to highlight the fine details in the image. With image sharpening, we want to enhance the high frequency components. This implies a spatial filter shape that has a high positive component at the center. So basically, the main job of sharpening filters are to highlight the fine details of the image and to provide you an image with a better quality. Now these are some of the graphs. As you can see, the low pass, high pass and band pass, these are mainly the frequency domain filters, and below there are their corresponding spatial domain counterparts. Now in sharpening, a high pass filter can be used to make an image appear sharper. These filters emphasize fine details in the image, the opposite of the low pass filter. Now, whenever we are filtering an image, each pixel is affected by its neighbor, and the net effect of filtering is moving information around the image. So this is how a high pass filter works. We also have high boost filtering under sharpening. A high pass filtered image may be computed also as the difference between the original image and a low pass filtered version of the image. So basically what we can say is high pass is nothing but the difference between the original and the low pass. If the original image is multiplied by an amplification factor W, a high boost or frequency enhanced image will result. So this was about sharp. Thank you.